This conference will now be recorded.
Testing 1 2 3. Testing 1 2 3.
Church today, I hit a deer with my car and wiped that out. I shouldn't need this, but I don't think I need this. Uh-oh. Well, welcome everybody. Max Lacey, our president, is under the weather a little bit today, so I'm here to welcome him and also present the speaker. And what we're doing today is remembering the 30th anniversary of the June 1995 flood here in Madison County. I don't know if any of y'all were here around that time in the flood. You could raise your hands if you were around at that time. Yeah, most of you were. So was I. So welcome. And our presentation today is given by Dr. Scott Eaton, professor of geology at James Madison University. And he's going to give us a bit about the science behind the flood and give some talking points and some points of how to do things better the next time or get ready for the next one, and some other things he will talk to us about as well. Now, he has a bachelor's degree in geology, he has a master's degree in geology, and he has a doctorate that he earned from the Department of Environmental Science at the University of Virginia. It turns out that the thesis he wrote for his doctorate was on this flood. So you can see he's well knowledgeable about that. Now, we will have question and answer afterwards, of course, and time for discussion. And we'll hopefully that some people might have some things that they would like to show about the flood, we have some things up here maybe to look at afterwards. But in the meantime, I'd like you to welcome Dr. Scott Eaton.
Thank you very much.
Yeah, you need to.
Well, thank you for that warm introduction, and thank you all for having me back here. It's hard to believe 30 years has gone by already after really the flood of memory. And I want to spend about 45 minutes just talking about what's happened in the past with the Madison County flood, or what we refer to as the Rapidan storm, but also look forward to some of the new techniques that we've discovered that's going to help future mappers identify flood deposits and maybe some early warning systems that are being developed that will help the next generation of citizens be aware of their surroundings. So again, thank you all for coming out here this afternoon here. Let's see. Christina may have to get you to help me with this one. What's going on with that one? There we go. You have to point that way. Okay. So want to just thank the Lillards for being such a wonderful second family to me. I've realized today coming over here, I've known them for half my life, so which just shows you how quickly time passes. As I tell both my boys, and Christine and I know that quite well. But Madison County has been a second home for me, and you guys have been wonderfully gracious, not just to me, but to other researchers who have tried to understand how the Earth works. And part of the theme I want to work through today is really without cooperation of landowners, it's really difficult to understand how the Earth works, specifically with geology. So you'll see that theme popping up over and over here today. So I'm a native Virginian. In fact, this is me back in the Mesozoic, back in 1981. These are not dinosaurs, but these are actually my buddies over here. And we're actually camping just on the edge of Kinsey Run. This was a scout overnight backpacking trip we had with the local council. And you can see that I'm trying not to get poisoned by my friend Jim Hallen with some half-baked, I think it was Bisquick. But I didn't eat it, but, and Ben, this is B.G. Benton, who you know over here too. He ate it and he didn't feel so well afterwards. But the point I remember about this camp out is we went by this place called Wolftown, and then Graves Mill, kind of ominous terms. But and then we couldn't get our tent pegs in the ground, and I came to discover why that was here later on, which you'll see, because we were actually on this ancient landslide deposit full of boulders that we just couldn't see. They were masked. And I'm of the age where I just barely remember Hurricane Camille, that is the flood of 1969, the flood of record for Nelson County, and really the largest natural disaster here in Virginia, where over 150 people perished. And I remember growing up in Crozet and reading the local Daily Progress and reading the articles of what happened with Camille and wishing I had been old enough to been able to go down there to actually see the damage. And I'm probably 13, 14 years old at the time, but I had a deep appreciation for how the mysteries of how the landscape behaved in rivers and floods. And there's two really good books if you want a good read on that flood. This is one of the original ones that came out. It's called Torn Land by a husband-wife team by the last name of Simpson. And it gives a really good account, chapter by chapter, from different people's perspectives of what happened during the Hurricane Camille event. And then later on, Stefan Betchel wrote a book called The Roar of the Heavens. And that's a more modern, more of the popular press version of what happened. But if you want a good read, I suggest those books. And you'll see there's a lot of parallels with what happened with Camille versus what happened here in Madison. And many of you are aware of the Hurricane Camille storm. It came crashing onto shore in Biloxi, Mississippi as Category 5, packing winds of over 200 miles an hour. And most of the damage that was really of noteworthiness was right here in the coast. And then, of course, this is back in '69 before we had really good Doppler radar. And so for most of us, that storm kind of disappeared. It was forgotten about until we didn't forget about it. It showed up here in the Blue Ridge, south of Charlottesville in Nelson County, and it got stalled out by a cold front. And it sat there for many, 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 many hours. And unfortunately, it happened overnight. And the result of that was it dumped 30 inches of rain overnight. And we know where else received 30 inches of rain, right here in Madison. And we talk about Hurricane Helene, we'll see that same number pop up, 30 inches of rain as well. Well, it was catastrophic because it did happen at night. People really had no sense of what was taking place except that they could smell the aroma of pine sap and sassafras being wrung out of the trees. And those that had that sixth sense, get out of the way, they did, and others did not make it. And unfortunately, over 150 people perished. That's 1% of the population of Nelson, which is still the largest single natural disaster here and loss of life in the Commonwealth. Well, now we turn our attention to Madison County. And this is probably everybody's passed over this bridge countless times. This is the US 29 bridge that crosses the Rapidan River. And at this point, I was working for VDOT. I was working as a geologist right out of school. Had a wonderful job looking at rocks and aggregate and traveling all over the state. But that morning, I was in the office, and I was hearing reports from my buddies next door who lived in Madison saying that the Rapidan Bridge was underwater. And I said, wait a minute, you must be mistaken. That must be some little country bridge you're talking about. Rapidan's a tall bridge. It's 30 feet off the ground, off the water. So I asked my boss, I said, I'm going to check out early. I'll be back later. And he said, no, you won't. I'll see you Monday, or whatever day it was. And so I took off and I got my dad's old pickup truck, and I wound my way up in the mountains and got up here in the Middle River. Notice I said that correctly, not the Conway, but I was always told it was the Middle from the folks up there, so I'm trying to honor that. And this is what we were met up here at Kinderhook, and we realized something huge had happened. This was not a normal storm, but there was a lot of water that had taken place through here. And eventually, we did make it to that Route 29 bridge. And rather than being the 3 feet of water it was today when I drove by, it had peaked over 30 feet. And that's equivalent to about 104,000 cubic feet per second of water passing through that bridge. And when we talked to the students about this, we call them the Dukes, being from JMU, I said, look, guys, if you took 29 semi-trucks, load them up, and let them pass by that bridge every second, fully loaded of water, that's how much water we're talking about. So it was really remarkable, and we realized that this was a very unusual storm over here. So if we think about, now I'm going to show you a couple graphs here, and we won't spend too much time on the specifics, but this was the gauge height this morning when I checked it. It's all online now. You can get data every 15 minutes. And 3 feet this morning, but on that day, it was over 32 feet. So it just shows you how much water was raging through there. And then the discharge, that is volume of water per time, it was 500 cubic feet per second this morning. Well, this actually underestimates it, but it was over 100,000 cubic feet per second. So huge amount of water. And then you might ask the question, well, how much water is that really? We'll actually take a look at that. But I thought that was the end of the story. I went back to work and got back to looking at rocks and minerals. That was my job. And we began to hear these reports that it wasn't just high water. There was more to the story. And talking to a lot of my friends from the West Coast, they often think of our Blue Ridge Mountains as being essentially geologically dead. There's not much happening. I mean, these are mountains that were formed a long time ago. And they've had hundreds of thousands of years, millions of years to just erode down to these little nubs that were once big mountains, perhaps the height of the Himalayas or maybe the Andes. We really don't know. But when we began to search around, we realized something big had happened. And these landscapes that had been stable through recorded history were no longer. And these mountains, such as Kirtley Mountain over here, had given way. And these stable slopes had become liquefied as a result of too much water being delivered too rapidly. And the soils and the rocks became liquid. They lost their strengths, their strength, and they came down in these different types of flows, such as debris flows, rock slides, landslides. And unfortunately, many of these flows came onto people's property, such as the Crossgrove property located over here. And then I actually went back to where I camped as a scout. Hadn't been that long. I'd been gone maybe 15 years, which is hard to believe. But I went back to that site, and this is Kinsey Run. This is part of the park over here. And just to orient you all, Graves Mill is right back over here. This is the Rapidan up through here. This is part of the Kinsey Run road up through here, and this is where the park begins. This is where the Jenkins property is over here. And I went back over here to Kinsey Run, where we'd camped, and there it is. No wonder we couldn't get our tent pegs into the ground. Didn't take an Eagle Scout to tell us that, right? So there it is, but it made a lot of sense. Sometimes you don't know what you're looking for until you know, until you have that knowledge. So there it was. But these weren't the only places, as you all are aware. Many, many farms and properties and people's livelihoods were greatly affected by this 30-plus inches of rain that fell. We have the Lillard Farm over here. It's a century farm. It's been around for over 100 years. And this area through here, and at one time there was a lot more going on over here. This is a recent photograph, but you can imagine going back in time, this is what the Lillards faced when they had two different landslides, debris flows that came out of the mountains and passed through their property and impacted their home. And the Lillards were the first ones who were very gracious, as many of you all were, to allow us to come on the property to begin our scientific investigations. And we were very, very thankful for that. And as we walked around very carefully, trying to show deep respect for the loss of property, it was just stunning. And I'm trying my best not to get emotional right now thinking about it. But this home was pushed forward by 30 feet. And thank God they were fine, because they were in an old battle axe of a ship, of a house. It was made well, and despite the house being hit by two different debris flows, they survived. The house was pushed forward by 30 feet, and they survived by going to the top floor. And Ruth has told me a few times the story of where she was in one part of the house, and she barely got back inside, and this part was torn loose, and she made it by a few seconds by the grace of God. There she is today, still with us. But it's a life changer, particularly for those of you who experienced it firsthand, and clearly those of us who've shared your stories with you. We came out as changed people as well, too. And then we had just across the creek over there, we had the Jenkins farm. Fortunately, their house was not damaged, but these were some of the boulders that were ejected out of the mountains by these large debris flows, multiple pulses. And there's one of my colleagues there for scale, just to show you the size and the power of the water and the sediment that pushed this material out. We also had in the backside of Graves Mill, back to the east, I think, is the Ayler Farm on the other side of Bluff Mountain. And clearly, I'm sure when these people set up shop, they had no idea that they were indeed sitting on these ancient debris flow deposits that we now recognize. So the losses, these are some of the numbers that I collected probably a decade ago, but I think they're still fairly accurate. There was 3 fatalities that I'm aware of, and there was over 20 people injured regionally. There's at least $80 million of private and public damage of property, at least $100 million in crop damage, and I think from a larger perspective, transformation of our lives, certainly, and the landscape that we see today. And I want to take you through some of the things that we discovered, and not just what discovered, but also what we see moving forward. So that could have been the end of the story. We could have survived the flood and the landslides and cleaned up and moved on and restarted our lives. But you all chose a different pathway. Because when these guys showed up, people from the government and people from academia, and they asked permission to be on your property to study what happened, rather than saying no, everybody, with the exception, I think, one person, dozens and dozens of people said, yes, you have our permission to be on our property. We'll ask this or that of you, but they were all very reasonable. And because of your generosity, we have a great data set that has helped many other people in science understand how landscapes behave. So this is as much as a tribute to your generosity as it is anything else. So each of these people had a role with the studies here in Madison County. Yes, my son, this is me when I was younger over there. You look a bit like me there, buddy. And this is Ben Morgan, former chief geologist of the U.S. Geological Survey. He, right before the flood, he decided he was going to go back into research. And I think the best 10 years of his time professionally was working with you all here in Madison County. This is Jerry Wazorak, world-renowned landslide mapper. And this is my colleague, Craig Cockle, who was my professor as a master's student, but he and I teamed up in this project because it took a lot of people to understand what was happening here. And this is my advisor from UVA. This is Alan Howard, and this is my wonderful mentor, Cullen Sherwood from JMU. So these are some of the larger players that helped understand and actually taught me how to understand landscapes and figure out what was happening here. So here are some of the questions we asked originally with this study, and we'll kind of add on to this as our time is, as we'll see how our time is doing here. We first of all wanted to ask the question, well, what was really going on with the storm, the meteorology, and the resulting hydrology afterwards? Secondly, let's look at some of the landforms and some of the surface processes that were taking place, not just today, but also what happened in the past. And then ask the big question, are these debris flows, are they just a blip in time? Are they just kind of a novelty? Or are they really significant in how the landscape is eroded and changed with time? So they may sound a bit esoteric, but they're actually quite practical, as you will see here as we move on. So let's just quickly go over what happened with the storm for those of you who may have just, who weren't here 30 years ago to see this firsthand. Well, in the Commonwealth, we receive moisture really from three primary sources. Sometimes it comes out of the Midwest, as we might refer to that as land recycled moisture. Sometimes we get moisture out of the Gulf from hurricanes, and tropical storms. And sometimes it just comes off the Atlantic. And it's the latter one is what we had happen here. We had a low pressure cell in that June that just sat off the coast for probably a couple days. And it just kept pumping more and more moisture right across the coastal plain, the Piedmont. Then when I got to the Blue Ridge, it's pretty steep here. Yes, we're old mountains, but we have a pretty good relief and landscape here. And a lot of that moisture was pushed upwards. And anybody who spent any time trying to hike into the park from this side knows that's a pretty good workout. And it's a good workout for clouds, too, as they begin to funnel their way up these places, these tight little mountain hollows. And as that water gets pushed up higher and higher into vapor form, it condenses pretty quickly. And this sat over here for a good day and just kept pushing that moisture up against the Blue Ridge. So the result of a strong cold front back in the Shenandoah Valley trapped the moisture in this side, combined with the steep topography we have here and as part of the Blue Ridge and the Piedmont. And then this was a very strong, persistent cell. Again, this was not a hurricane, but this was just kind of it was a low pressure system parked off the coast, and then parts of it came on shore here and stuck around here in this part of Madison County in green for a long time. Well, the result of that was, as we already have alluded to, we've got over 30 inches of rain in 18 hours. And that's not for the entire area, but that ground zero happened to be Graves Mill right through there. And so all that moisture had to go somewhere. And we had, at this point, very different than what happened with Hurricane Camille in 1969. 1995, we finally had some pretty good radar, some good next-rad Doppler radar. We could track the cell of the center of each of the rain, starting over here up towards Syria at 9 in the morning, and then it came on down through here by 10, 11. Graves Mill is right there. Had lunch down over here, and then began to track back up through here, then exited across the Blue Ridge over the Shenandoah Valley by about 3 o'clock. And as it did this, it continued to drop rain upon more rain and more rain, and the water had no place to go but out. And this is one of the reasons why the land essentially lost its strength. It became liquefied, and this is why we had these debris flows. So when the clouds lifted, This was what the landscape looked like minus the redness here. This is infrared photography that was flown not too long after the flood happened. And so what we have here is the white areas are the fresh landslide deposits coming out of the Blue Ridge, coming out of the mountains. This is the Graves Mill right through here. This is the Rapidan coming through here. This is Kinsey Run right through here. And that study mapped over 1,000 individual landslides, some which took place on park property, some which actually came on individuals' property as well. And we can see the result of that coming down through here. So getting back to this question, was this a really big flood? I mean, is this out of the ordinary? Well, one of the ways we test that is to ask the question, well, how does this stack up with other floods that we know about for eastern North America? And so this is called the flood envelope curve. And what we do is we plot how big my basin is that's catching the water and how big that flood is, the discharge. And you can see that this is the maximum recorded data set we have for eastern North America. And look where we are. Graves Mill right at the top. US 29 Bridge right at the top. So the punchline here is you couldn't really get much bigger flood if you wanted one. Not that you would, but it was about as big of a flood as you could ever imagine for that size of the basin. So we pretty much maxed out what we could expect to have, at least from this data set over here. So is this a one-off? Was this kind of a one and done, or do we have any evidence of past events of these types of big floods? Well, let's see what the soil and the surficial deposits show us. So I'm going to focus on this term called debris flow, and has a couple different definitions, but the most simplest one is it's a mass movement. It's a gravity type of deposit being pulled down by the earth, and it's a mixture of water, loose rock, soil, and other debris that moves down almost like concrete. We use the word slurry over here. And when I was in school, we thought about these debris flow deposits and the landforms. They would form like these fans, debris flow fans, or sometimes called alluvial fans. We think about these being out west, and say in the Basin Range and Death Valley. At least that's what I learned in school. Or maybe they're in more exotic places like landscapes that are really steep, like Venezuela. So this is a debris flow event from 1999 that the USGS worked on. And this whole area was impacted by these pulses of landslides and debris flows that sadly claimed 30,000 people. It was a terrible event. And I was able to help out with this because of what I was able to do with you all here in Madison County. And so we think about these as being those fan-like deposits that are formed as that debris flow comes to rest. Well then, back in 1969 from Hurricane Camille, we kind of got surprised because this was not really recognized as being these debris flows or debris fans. And we began to think that, well, maybe they are not just relic deposits or old deposits, but maybe they're actually active still today. And I remember talking to Scooty, and he had been down here in Nelson County as part of the relief effort after this flood happened. And he came back home to his house, and he looked around, and he said, I may not be a geologist, but I know a lot about the land because I've been farming it my whole life. And I think we might have that here too. And he was prophetic, because that is indeed what happened. There's a Lillard home right there, and he called it right. He actually identified debris fan and debris flow deposits before we ever got our feet out here. So once again, the farmers have a lot of wonderful knowledge that we have a lot to learn from. And of course, it wasn't just the Lillard property. It was many, many dozens of different properties that received these debris flow deposits that came down and came to rest on the landscape. So we began to do some mapping. And the U.S. Geological Survey, that team that I was part of, we put out 4 different maps that covered, I think, 250 square miles, which I was shocked when I saw that number. It's pretty big. But we were able to get out while the land was still wide open from those scars and the cuts from the water and see the deposits in a way that nobody had ever been able to see before. And so all the colored area you see through here, these are all ancient landslide and flooding deposits. This is Graves Mill, as you can see here, and you can see that much of the flatlands and the gentle slopes are actually ancient flood and landslide deposits. And that's kind of true for much of the Blue Ridge as we go up and down the eastern slopes through here. And then we're able to get onto a landowner's property that you all gave us permission. And we could see older debris flow deposits here, followed by even older debris flow deposits here. And some of these are pretty recent. And when I say recent, the last 1,500 years, which geologically is pretty recent. I know. It's all about location too, right, as you'll see. But then we said, well, what about in the past? Well, by golly, there's even older deposits here and even older deposits over here that if you take your trowel, you can actually write your name in cursive if you want to. It's really, this material is so soft, hard granite rock. It's been there, in some cases, 500,000 years, that you can easily put your trowel or your knife or even your finger into. So this is nothing new under the sun. This has been going on for as long as we know, going back at least 500,000 years, 500,000 years. And then what was a real shocker was we just thought, well, we're just looking at debris flows. Well, up here in Kinsey Run, we discovered something that did not make sense. And we pulled out this piece of wood out of this bog that had been there for apparently a long time. Because when we did a radiocarbon date on this, it came back to be about 24,000 years before present. And it wasn't just old, it was something that doesn't belong here today. It was red spruce. And if you go looking for red spruce today, you're not going to find it at 1,000 feet elevation, which is where this is today. You've got to go about 4,000 feet up to, say, spruce knob or dolly sods. So you begin to think, well, gosh, what does that tell us about our climate at the time, 24,000 years ago? It's probably pretty cold in order to support, or certainly colder to support red spruce to be here in Virginia back in the day. And then, even equally as bizarre, is we began to look at the layering of these sediments. And it wasn't debris flow. And I'd had a pretty good sedimentology course coming along through college. I couldn't figure it out. And we began to bring in expert after expert after expert. And we were all kind of stumped. And then we finally brought this guy in from Australia who had spent time up in Alaska. He said, you've got something here that has not been seen in this part of the Blue Ridge before. You've got a near glacial deposit. It's called periglacial, or essentially a frozen ground deposit. And I said, wait a minute, that's pretty radical, don't you think? And he said, well, think about it, Scott. We're right here. We had the great ice box of the glaciers just 250 miles north of us. And they were there for a long time. We're talking tens of thousands of years in some cases, the glaciers just being parked there. And when I worked in the restaurant, if you wanted to cool off in the summer, you hang out in front of the deep freeze, keep that door open. Well, imagine Virginia being there in the deep freeze for a long time, and you end up freezing the ground, and you end up creating a top layer that freezes and thaws throughout the season, whereas the bottom layer is permanently frozen. So in the summer, when it's warmer and we have a little more daylight, that top layer is going to thaw. And there's no place for that water to go except across the surface. And so it moves almost like this gelatinous material. It oozes across the landscape. So you end up getting this thing that we might call a permafrost feature. So let's take a look at that real briefly. These are not my images, but these are these lobes of gelatin, that's my term, of water and soil that has no place to go except downward. And they ooze across the landscape. Well, if you do a cut through these, if you were to cut through these, they look just like this. This, folks, is right here in Madison County. It's up in the park. It's up in Kinsey Run. This was the first documented section that I'm aware of in this region. We had some places up in Pennsylvania, but now that we've seen this, because of your all's generosity and the access, we found these in multiple places throughout Madison. Workers are seeing this everywhere now. But you all were the springboard for that, for allowing us to actually discover that. So it tells us something about Virginia's past climate here in the past. It was pretty cold for at least 24,000 years ago. And also because of your generosity, we were able to publish a paper for other workers to see this. And there it is. So again, because of what you all were able to do for us, we're able to spread the knowledge to other folks that were able to find these deposits and make some sense out of the landscape. Well, maybe the bigger question is, how often do these debris flows happen? Should we worry about them for round 2 down the road? Well, I think the best way of asking that question in some ways is to see what's happened here in the past. And so here we have an older debris flow deposit, an older one there, there's another one down there, and there might be one through here. But we can actually go through and count these deposits, and in many cases, there is buried treasure. And this treasure here is carbon. Sometimes it's carbon from a forest fire through here. Sometimes it's pieces of wood, and sometimes it can just be other types of carbon material. But we were able to collect a whole bunch of carbon, probably 24 samples, and get the ages of those samples, and then it tells us when that debris flow came through and buried that carbon deposit, giving us a pretty close range of the age. And so, again, because of the generous access provided by the landowners, each of these dots represent a different piece of property throughout Madison. And each of those dots represent a radiocarbon age. And you can see that some of these line up quite nicely. So each of these lines here represent a different episode of debris flow activity right here in the Rapidan, Robinson, Middle River basins as a result of that. So if we look at the frequencies of these, there's a little bit of a gap in there. Who knows what happened? Don't know. But it's roughly every 2,000 to 3,000 years for the frequency, so for these very small basins, right? Doesn't mean you can set your watch by it. As we've seen back-to-back 100-year floods, right? We had this flood of 95, and then Hurricane Fran reared its ugly head a year later. 2 back-to-back big floods within a year of each other. So we have to be careful about setting our watches by this frequency, right? Just like we have a big long break over here with nothing happening. Well, then we ask the question, well, is this kind of a one-off? Are we kind of unique here in Madison, which I'd argue in some ways we are culturally in a wonderful way, but geologically, this is going on other places too. And Craig Cockle did some work down in Nelson County right after Camille came through in '69. There's that deposit. And this is back when you could do this a little easier. He had some grad students, and he said, well, if you want to graduate, you're going to have to come out with me for a day and dig his hole. And so they dug his hole. I think he fed him, at least gave him some water. But there that is. That's an older debris flow deposit, 6,300 years, and there's a 10,005 debris flow deposit. So these are happening all over up and down the Blue Ridge, which is no surprise now, but in those days it was kind of, well, we don't really know yet. So then we can use that knowledge to ask the question, well, are these really significant? Do they actually help mountains go from being really steep and tall to being more of our majestic rolling topography we have here in the Blue Ridge? Well, let me just show you one study we did here and see if I can make some sense of it with y'all. The Jenkins were also very generous, as many of you all were, for letting us on the property. In fact, we camped out on their property, I think, for a summer. And in this study over here, we actually went through and said, well, let's just take this little basin through here that's been hit pretty hard by the debris flows. And let's see actually if we can measure the volume of how much sediment was flushed out of there. And see if that makes a difference. See if we can ask the question, well, is that a big deal compared to what happens long term with sediment being removed from a basin or any place? And so we measured the basin, 0.4 of a square kilometer. And then we spent a summer up there, and we actually began to measure how much material had been there, but that had been removed by the storm of 1995. And so the idea is that we started with what it looked like before. We weren't there, of course, but we got there afterwards, and we could see where part of the channel still was there. And then we projected across these lines and said, well, the area under the curve through here is probably that slice that's been flushed out of there, plus or minus, say, 10%. So we did lots of cross sections, just recreating what used to be there, and then did that for many, many points all the way down. and then added it up. And we estimated that about 13,300 some change cubic meters of material was flushed out in that single event. Now you might be thinking, well, where are you going with this, Scott? Well, let's say this number here represents the volume of the cube. Okay, that's a volume. We could reconstruct that. And if we know the area of my basin, so let's say this is my area of my basin through here, and we lose an entire volume, volume is equal to area times depth. I can solve for depth. And when I figure out what the depth is, given the area and the volume, I've discovered that on average, I lost about not quite 2 inches, about 3.4 centimeters of land. The land was lowered 3.5 centimeters from that single event. And that's how geologists think about long-term erosion of landscapes. How did the Blue Ridge go from where it is today from something much mightier and greater? So the question then was, well, is this only happening here on Mr. Jenkins' property? Well, we're able to actually get a paper out from this, and again, these were people that had worked on Ural's property, and this is out in the press now for people to use for their studies. But we also did one right next door, and that's my 3.4 centimeter number, and this is the one next door, and for science, that's pretty close. They're within the same unit of rounding error. And then I said, well, what about happened down in Nelson County from Hurricane Camille? These numbers are all pretty close when you just do first approximations. So the punchline here is when we have these big events, the landscape is lowered a few inches. Whether you're here in Madison, Nelson, and probably other places as well. We haven't done other studies yet because we haven't had a big event since then until this past year, as we'll talk about. So now the question is, well, these episodic events that strike the landscape, did they significantly lower the land, or are they just part of a rounding error in the big picture? Well, we went back to Nelson County, and this is, of course, the Madison area through here, and we were able to figure out, again, the frequency of our debris flows. We said every 2,500 years, every 2,000 to 3,000 years. So if we go off the coast of Virginia and look at long-term sediment records, we have a pretty good idea of how long it takes the land to lower. We know the long-term erosion rate, and there's a couple different techniques we use for that. But we don't know if it happens at once, if it happens gradually. But just for argument's sake, let's say over 2,500 years, our land gets lowered about 5 centimeters, okay? Over 2,500 years. In one day, half of that lowering took place. I thought, well, that sounds like catastrophism in some ways, and that's okay. That has a role in geology as well. So does uniformitarianism as well, because we have lots of examples where there's room for both of those. Well, let's check out Nelson County. We have good data for that. A little longer return interval for our debris flows, 3,500 years. In one day, half of that happened. That's kind of cool. So this was actually, it was an eye-opener for a lot of us in the geological community. At least it was for me. And so we decided, and we talked to some old-timers who'd been doing this for a long time, and they said, yeah, you guys you're right on with this, because it's those small storms that happen a lot that move the small material, like the sand, the silt, and the clay, the gravel. But you need a lot of energy to eject those big boulders out of the mountains. So you need the big storms that don't come along very often, thank goodness, right? They spit them out. And somewhere here in those debris fans is that kind of that translational period where you let them break down until they're small enough to allow these rivers to actually move them out. So it was a really wonderful study. And once again, because of your generosity, here is another paper that's out there for people to use for their work at other parts throughout, not just throughout the Appalachians, but other mountainous areas as well. So again, thank you for that. So what are some of our lessons that we've learned as a result of what we've done here? Well, first of all, on very small basins, the probability is quite small, but still there. I want to make sure we're on the same page with that. that maybe every 2,000 to 3,000 years we can expect to have an event like we had here in Madison County. But it's all about your location, right? Because there's some places that gave up the land and spit out the rocks, and other places that still are waiting to happen because they didn't have the 30 inches of rain. So we could have that same cell move over a few neighborhoods, and we could still have activity. So we have to be very careful of that. If we scale out in the size of, say, the two Virginias, now we're looking at a frequency of maybe every 15 to 20 years. And you can see with this image over here, number 4 was the Madison storm, but it also struck western Albemarle County. It also hit Buena Vista over in the Valley and Ridge, and it even hit part of near Front Royal, this little town called Browntown. So you can see that these storms can spread quite a ways throughout a territory. And then if we look at the entire Appalachians, that is the central and the southern Appalachians south of the glacial margins, we're looking at an event about every 3 years. And sometimes we'll go a long time where nothing will happen, and other times we'll be back to back. So from a land use planning, or as someone who's trying to be an advisor or in charge of emergency management for a large area, you want to keep an eye on whether you're looking at a large area you're trying to manage or a very small area, because those numbers and those geographic distributions matter. And then the question is, well, is that gun barrel still loaded with sediment, or did we flush it out last time? And that's where we actually physically, in some cases, go up these mountain hollows and see what's there. And we spent one summer about 10 years ago with the folks at the Virginia Geological Survey to see if we still had debris in these mountain hollows. This is some work from Page County across the ridge. But in most cases, many of these mountain hollows, even though some of those basins failed, they are still loaded up with material and other hollows that still have the potential to move. So we have to be watchful for that. What is interesting is once we fill up these small areas, these first order streams with debris, and they can take a long time to do this, they are then evacuated as a result of too much water showing up. We can talk about what those threshold curves might be to get material moving, but then we evacuate those hollows, and it takes some time to actually refill that gun barrel, get that material moving again. And hopefully it takes a long time to refill those, right? Because if there's no ammunition, it's more difficult to have debris flows show up on people's property down low. And then we've been working on these, what we refer to as the rainfall thresholds. And Christine and I were talking about it this morning that there's been some really good advances with this technology. This is Hurricane Isabel moving up through central Virginia. And it did not trigger any debris flows, but it was right at the threshold. There were some places that received 13, 14 inches of rain. One place received 20 inches of rain, but it must not have been the right sequence for landslides to take place. But what we do have more of that we didn't have back in 1995 is we have the Virginia I-flow systems. And many of you may be aware of this, but this is a series of rain gauge networks linked together, and they tell us the rainfall totals every 15 minutes. That's a very valuable tool for helping essentially our emergency services people to help advise whether we need to evacuate people from the lowlands or maybe even in the uplands where we have the potential for debris flows. And this is, I think, kind of the crown jewel of some of the work that you helped us with here. Most of this data is right here from Madison County. And we call this the debris flow threshold curve. And over here on the x-axis, we have how long the storm is taking place. We call that the duration. On the y-axis is the intensity. And this curve is that threshold between where the land's going to remain stable versus when we should begin to worry that the land's going to lose its strength and have debris flows. And each of these data points were ones that we were able to collect through your all's help, through your all's records of saying, yep, we had this amount of rain, or here is a bucket that filled up, here is a 55-gallon drum. And because of that, this is one of the better curves I think we have anywhere along the East Coast. At one point, the National Weather Service was trying to link this up with some of their early warning systems to be better informed, and my hope is that project will hopefully come to fruition. But if we could have more of these types of threshold curves, then when we begin to cross from here to here, we can begin to warn our citizens that there is some danger potential from upslope areas. And then we have the healing of the landscape. So here's a series of Google Earth images going from just 2 years after the event. This is Kinsey Run, so this is the Jenkins property over here. There it is, 2003, 2008, 2011, 2022. So here's my question. What happens when our generation moves on and the new generation comes in, and you try to explain to them this big flood that happened a while back? How are you going to know? And how do you recognize what's been covered up in vegetation? I took my students up here for the first 20 years, and the last 10 years it's like going through a jungle. And they don't even believe me when I take them up there. I mean, they believe me, but you know, it's a hard sell. And so the question is, what are some other tools we have that we can implement to help us locate past flood deposits that were in place long before we were here? Well, let's take a look at what we do have. So here's Kinsey Run. And when I was mapping, this is the tool I had. It was a fantastic tool. It's a 7.5-minute topographic map. I love them. And I still like to go back to these, but I can tell, just because I've seen enough of this is probably a landslide deposit over here. But how much better we can use this? So many of you are aware of a LiDAR, that is light detecting and ranging. It's essentially radar, but instead of using radio waves, we're using light beams. And the entire state has now been flown with a couple small slivers, and it's just fantastic. This here is the same as, as this here, as this here. What a wonderful tool. I told my dad about this. He's former military. And I said, you won't believe this tool we have. It's called LiDAR. And he said, yeah, we've had it for 20 years. And he's a geologist too. I said, I still love you, Dad. Anyway, I wish this would have been available when we were mapping. But what's wonderful is the next generation of mappers and geologists have this now. And they can begin to zoom in on places that say, well, what's happening over here? Was there ever a flood here? Well, let's go look. Well, by golly, there it is. There's a deposit. There's the deposit. These are streams coming in. This is rock over here. These are all transported deposits from floods and landslides. And now we begin to start having an idea of where to go look versus using a topographic map, which was wonderful, but it wasn't as efficient as having LiDAR. But I'll show my bias here. And even though I'm not a Virginia Tech graduate, I love soils, and they have one of the best soils department anywhere in the U.S. JMU is pretty good too, but we're trying to catch up with them. But I'm still a believer in using soils as a really good first approximation for telling us whether the soils have been transported or whether they've been there for a long time, weathering over the rock beneath. And so, for example, this is the Jenkins farm over here, and you guys have a fantastic soil survey. It was done by a gentleman by the name of John Elder, and he nailed it. He was finding deposits that we didn't even see the first time, but he wasn't a geologist, but he had that sixth sense of knowing to read the landscape, and he was a pretty incredible guy. And so you go out and you want to use the soils maps, and even better, you want to ask permission from the landowner to allow you to dig some pits and to actually examine the soil to see if it's transported, how old it might be, its nature of deposits. And then you can begin to make some recommendations of whether should we be worried that this is the next flood to happen because it's a relatively young soil, or something that's 500,000 years old. It's been there for a very, very long time. And these sites are just a few 50 yards apart from each other, but they're very different in how they were formed and their age. So moving forward, using LiDAR, using the soils maps, and certainly doing field investigations is essential for kind of unraveling and deciphering what's happened in the past. We've got about 10 minutes left, so I'll kind of wrap this up over here. Hazard mapping. It's been very useful to have the LiDAR to look at areas that, this is from Hurricane Camille, but you can see even 55 years later, we can still see where deposits were put down from the Camille event. And up close, you can see the head scars on the LiDAR. It's really powerful. We still have people that want to put their homes right here in the gully, and all you can do is advise. That's our job as scientists. Is here's the data, you decide what you want to do with it. And it's a wonderful, beautiful home, but it is in harm's way. And yeah, so there's a close-up of those slides through there, where the debris flows initiated, coming through there. I don't know about that one, but there's a lot of material still left up over in here. And this is one from 100 years ago. This is up in Pennsylvania. It was a hand sketch over here. You can see after 100 years, it's still there. So as the LiDAR gets better, I think we'll have more opportunities to see what's happened here in the past. So what are we doing now as geologists with this knowledge that was really granted by you all early on back in 1995 plus? Well, there are a number of geologists through state and federal surveys that are making landslide maps of counties. This one is in our neighbor sister county to the south of us here, Albemarle and Nelson. And Ann Witt and Matt Heller, both geologists at the Virginia State Survey, they've done a fantastic job taking some of the techniques that were developed here in Madison, and they're going up and down the Blue Ridge for any county that would like to partner with the state survey to create these hazard maps. And they're not even necessarily hazard maps, but they show us where the past deposits have been, and sometimes they have run-out models as well to approximate where debris flows may end up. And what I want to point out here is that these orange areas, I think they're orange, are these ancient debris flow deposits, but they also happen to coincide where some of the orchards are as well. So I think this is the Childs Orchard over here. That's probably Mr. Whalen's orchard there, and one of these two are the Henley's orchards. When I was a young instructor, I had a high school student do a project with me out of Western Albemarle. And this is Nathan Kruger, by the way. And Nathan wanted to do some geology, and he found that 80% of the orchards in Albemarle happened to be over ancient debris flow deposits. So the farmers again knew something about that. They know that those soils are ideal for growing fruit, especially peaches and apples. So if I was going to go back and quickly map debris flow deposits, I'd probably pull up the old records of the orchard. They'd probably be almost on top of each other. And then we can look at the next big storm. And we went a long time. And I'll be honest with you, we love studying the storms. We despise the amount of damage that it inflicts on people and the loss of property. So we're kind of grateful that nothing had happened until it happened here this past fall. And so we did have Hurricane Helene that came screaming up the coast through here as a Category 4, I believe. It came onto shore, and it's still in the works. We still are trying to figure out all the mechanics behind it, and certainly the geology and the debris flow activity behind that. At this point, it appears there's at least 250 fatalities. There's that number still might be low. There's 126,000 homes that are damaged, and there's at least $75 billion of losses. And this one was much bigger than what we had here in Madison, obviously, because it impacted multiple states. It came up through the southeast, and it parked itself right here in the southern Appalachians. And if you look at these numbers over here, this is for the rainfall. There's that number once again, 30 inches of rain. There it is, over and over and over. 30 inches for Camille, for Madison, and now for the Hurricane Helene event over here. And we also noted that for Helene, it didn't impact just one area. It impacted many, many states. And I remember talking to Craig Cockle about this about 10 years ago, and I said, Craig, we're seeing debris flow deposits the same age up and down the Blue Ridge. He said, yeah, I think that was probably a regional event. We don't have a record of one. Well, now we do. Because I think Helene is probably a lot like some of the ones that certainly have happened in the past. Because it didn't happen just one basin, it happened to many, many different states. And you ask the question, well, what could these people do? This is in western North Carolina. This is in Marshall. I've not been down there yet, but I hope to get down there at some point to see some of the work that's being done for the research and the cleanup. But many of these people have no other place to build, right? It's a gorgeous place. My father's from eastern Kentucky, where it's a lot like this, very steep mountainous terrain, and the only place to build is in the flatlands or in the debris flow fans. So it's kind of it's kind of the price we pay to live in paradise, because these are beautiful places. But I guess the good news is with the LIDAR, we can begin to see patterns of where old flood deposits and activity have happened along with debris flow events. And we can just zoom in here. We can see that all this area through here has been impacted in the past from landslide and from flooding events. So if nothing else, people can begin to make informed decisions of, do I want to build here? Do I want to stay here? What's the frequency of these events here? And each person can decide with the data that's been given them as a result of that. And so I would argue that the Rapidan storm, or the Madison County storm, has really been the springboard for much of our understanding of how we think about Appalachian landslides and their deposits. But it couldn't have happened without you all's cooperation. And I really mean that sincerely, because we've worked many different areas, and sometimes you're welcomed into people's property, say, come on board, look around, and a lot of times you get shut out. And there's good reasons for everything. But without your all's help back in the 90s, and continuing your all's help even today, your graciousness has allowed a lot of us to collect knowledge and then to spread it to other workers who are now taking that information and not just mapping it throughout the Appalachians, but really mapping throughout much of the world. So again, thank you for allowing us to be part of your family, and thank you for coming out. I kept you all here way too long, but I'm glad to take a few questions. Yes, ma'am.
I'm just wondering about farms in Madison where there's a line of big rocks.
Sure.
Caused by volcanoes that took place a long time ago? Or was there, more of a mountainous area where the floods?
So the question is, when you see a big long line of rocks that are popping up through the land, is that from past volcanic activity, or is it from something else? We do have some igneous dikes that do cut through the countryside through here. So that's probably, some of those dikes go back 500 million years ago. Some of them go back 65 million. But a lot of times there's a layer of resistant minerals in those rocks that over time, and it's usually quartz, or it's jasper or something like that, or epidote. And over time, that stands high and proud to erosion. It's just really tough rock. And the softer rock around that weathers faster. And so as a result, over time, you've got these ridges of rock that stick up. So it could be, it's probably just a resistant layer of minerals that you're seeing. But it doesn't rule out some sort of igneous intrusion from the past. Yes, sir.
Forgive me as I fumble through this.
No,
one.
please do.
On one of your charts up there, you had the surface area of the mountainside was 0.4 square kilometers.
Yes, sir.
How do you calculate the surface area of a three-dimensional thing? Like if you have a cone,
Yeah.
the surface area of the cone can be much larger than if you look at a 2D map of that circle.
I'm going to disappoint you here. We literally took a topographic map and we digitized around the outside and said, here's my drainage basin. So that's my area. And then the volume that we measured flushed out. And so a volume divided by the area gives you the depth. And we did it that basic. Just the 2D, yeah. Now with LIDAR, we could probably do a lot more with that, couldn't we? But back in the 90s, that was the best we could pull off. Yeah. I know. It's a great question. Yes.
Yes, and is there, by any chance, is there any way that something in the earth, the minerals or whatever, attracts the storm's pathway, the water?
Good question. I'm not aware of anything in magnetic-wise that would attract a storm through a certain area. I think you have better luck of having the ridges in those valleys kind of funneling the water up a certain direction. So if you think about like the layout of much of our Blue Ridge. You have your main spine of your Blue Ridge, but you have a whole bunch of these little side ridges that come off. And where they're tight and they're shaped like a funnel, it's almost like an invitation to say, come on up. And up the water goes. And that's probably a better direction of where the storms are going to go. So, for example, Big Meadows is really wet, and I suspect a lot of that's because of the funneling effect of those storms coming out of the east and also out of the west. Yes. Yes, sir. Oh, gosh. Yeah. I have. So we've talked a lot about this before, and I appreciate the question for the general audience. James Madison said, knowledge is power, and the more knowledge we have of the frequency of these events that happen, the better we can make those decisions. So I think moving forward from a planning commission, I would say as long as people should be aware of what's happened in the past, the types of deposits they're on, and if systems like the iFlow can be better implemented through emergency warnings to get people out sooner, especially at nighttime. That's what worries me, is when these storms come at night and most people aren't paying attention, like in Camille. That's probably what I would focus on, is making sure that there's a quick reaction time, that citizens can get word that water's rising or we're crossing that debris flow threshold, that we want to get you to better ground and not in the chute of where the debris flow could come through. That's probably the best advice I would give planners. Would you agree with that? My wife is also a debris flow expert, so I often come back to her as well. Yes, ma'am.
There have been several small earthquakes in the area.
Yeah.
Did that have an effect on the rock coming down over the mountain?
So we've had a couple tremblers here, earthquakes, and if something is on the threshold of moving, it could come down, but a lot of those are just rock falls versus debris flows. And so I think we were concerned after the first few years of the flood that there was still a lot of material that's unstable, and I think we all talked about this in the Lillard House one time. But after about 5 to 7 years, that vegetation comes screaming back, and it puts a net on everything and kind of locks it together. So luckily we're not out west where there's no vegetation. But out here in Virginia, if you don't mow your grass for 10 days, right? She's being very patient in a great way. It comes back. So I wouldn't worry about it at this point, but if it was right after the flood, yeah, I'd start kind of keeping an open eye for it. Yeah. Yes, sir.
Is it reasonable for us to extrapolate the debris flows from the time the mountains were at their original height and continuing down into the Piedmont, or is that just a wag?
Well, our data set goes back 30,000 years. And after that, you just don't know. You don't know how climate's changed. It is interesting that we can go back 2 million years in time. And 2 million years ago is when North America and South America came together, and they changed the worldwide circulation for ocean currents and for heat distribution. But at the same time, the Himalayas were formed, and it set off this cycle of 100,000-year cycles, where the first 90,000 years it's cold, creating our ice age type deposits, not glacial, but cold climate, followed by a really warm period over there. So you could probably go back a couple million years and say what we've had happen today is probably what's happened in the past. But what's interesting is if our Earth has been cold for 90% of the time over the last 2 million years, it means that today, this 10% of the time, we're actually hanging out in a climate that's actually quite warm compared to what's around us that was formed during a very colder time. And it's kind of mind-boggling when you think about that, because we look around the landscape and we say, oh, these big block fields and all we see, that was formed today. No, a lot of it was formed back when the Earth was much colder. So you can almost set your watch by it, the cold, and then we're in the warm period right now. So I wouldn't want to go too far back in the time. Maybe, I don't even want to speculate. My data go back to 30,000 years. I'll hold it there. Yeah. Could be safe about it, conservative. Yes. We've talked about that. I think AI is going to eventually catch up a lot of areas, certainly in geology. But I think there's so many wrinkles with the subtlety of how the science works. There'll be some areas where it'll be helpful for trying to find breaks and say the LiDAR, where you can say, hey, this is odd. Or right now we use some automated mapping to find sinkholes, some faults. And I think there'll be a role in it, but I think you're going to always need the human mind for the art of seeing what you see. Yeah. No. Because a lot of times it tells us it's X and it's Y to the second degree. Yeah.
Has anybody been interested in finding Indian artifacts in those debris fields that would show the age of when the Indians were here and that sort of thing?
So many of you all know Carol Nash, our resident archaeologist. And Christine and I were talking about this a few months ago. Carol and I both discovered separately that, well, she discovered that the American Indians vacated the Rapidan Valley at the same time the last debris flow came through back 1,500 years ago. We never got that paper published. We should have done it. She's still working too, so we'll have to circle back. But the debris flow certainly, I shouldn't say certainly, the data suggests that the debris flows did affect early human occupation of the valleys. And yeah, I find that fascinating. There's always people curious and finding artifacts from the past, but it's something that we don't necessarily do as geologists. Yeah.
Well, Carol has spoken to us a couple of times.
Oh, yeah.
She visited me, so,
Yeah, she's great.
she's learned a lot about the Indians as
Yes,
well,
sir.
so. Now, somebody asked a question about, like, is there a magnetic field or something that could affect the rainfall? And, well, where I live in Rochelle, we've had these droughts for the past couple of years, and when I look at my weather and see where the rain is happening, it seems like it splits about Ruckersville and goes east, and then it gets on the other side of the mountains or right on the edge of the mountains, and there's a big white hole right there over Rochelle. So
Sounds like Stanton.
years if that if it could possibly be something in the soil that's causing that.
I'm not aware of it. A lot of it's topography, but sometimes it's just bad luck, or I don't know. Maybe we have the same issue where we are in Augusta County. Yeah, very dry. Are there any other questions? All right.
Some items up here and get afterwards. Doing this is just
My
been
pleasure.
fascinating.